In this illustration, we intend to simulate the ring-shaped steel plate shear wall under the cyclic loading in the Abaqus software. In the right picture, the laboratory model, and in the left picture, the sample having been simulated in the Abaqus software can be observed. In this model, the horizontal members are columns and the vertical members are beams. In this problem, a hysteresis loading will be applied to the left beam, and then the hysteresis diagram of the model will be drawn. In this picture, the hysteresis diagram having been obtained from the Abaqus software has been compared with the laboratory results. In this picture, you can observe the deformation of the model under the cyclic loading. Actually, we intend to simulate this article in the Abaqus software. The article is entitled Experimental Study of Ring-Shaped Steel Plate Shear Walls. In the next step, I click on Create Part. I intend to create geometric shape of the beam. Here, I will select 3D, deformable, shell and extrusion, and enter approximate size equal to 1000 and continue. I will draw a horizontal line. I'll enter its length equal to 165 millimeters. The length of the web is equal to 310 millimeters. Okay, done. Here, first I will enter the geometric shape of beam into the assembly module. In the next step, I'll enter the geometric shape of shear panel into the assembly section. First, I will rotate shear panel 90 degrees about Z-axis. Then, I will rotate that 90 degrees about Y-axis. And after that, put it in a suitable place. In the next step, I'll enter the geometric shape of column into the assembly module and rotate that 90 degrees about X-axis. I'll click on Create Section. I intend to define Shear Panel section. Here I will select shell and homogeneous. Continue. The thickness of shear panel is equal to 12.7 millimeters and OK. I will click on Assign Section, select Shear Panel, Done, and OK. I'll click on Seed Parts, consider approximate global size equal to 15 millimeters for Shear Panel. Click on Assign Mesh Control. Here select Quad and then Medial Axis. OK. After that, I click on Mesh Part and Yes. In the next step, we intend to draw the hysteresis diagram of the model. Actually, we intend to draw this diagram in the Abaqus software. The horizontal axis is rotation, the unit of which is percent, and the vertical axis is force. I'll click on Create XY Data, select ODB Field Output. Continue. Here first select Unique Nodal, then RF3, then U3. Here I select set 22 that is related to the place of cyclic loading and click on Save. I'll click on Create XY Data, select Operate on XY Data, Continue. Here I will select all reaction forces. Here I will select Sum option, then click on Add to Expression, and then click on Save As. In this manner, all reaction forces will be added all together. In the next step, I'll select U3 and divide that by 864 millimeters. Actually, 864 millimeters represents the distance between the two pins. Then multiply that by 100. In the next step, I will select Combine. First, select Rotation, then select Force and click on Save As. Here, you observe the hysteresis diagram of the model. I will transfer the diagram to the Excel software. The first column is rotation. The second column is force, the unit of which is Newton. Here, the diagram having been drawn with blue color is the one having been obtained from the Abaqus software. As you observe, the results obtained from the Abaqus software are really close to the results mentioned in the article, indicating that the question has been simulated correctly in the Abaqus software. Actually, the results obtained from the Abaqus software are completely concordant with those gained from laboratory tests.